Now the simulation has finished 1000 steps, and you can see the evolution of these residues. There is a significant reduction in SDR, but for the other quantities, the convergence is okay. And if you want, you can still continue with the iterations. But for me to demonstrate the result, just stopping here. Okay, so and we will analyze the result, the CFD result, or we do the post-processing based on the current simulation. And also going to the next tab, we can see the downforce and the drag evolution, how they changes. And eventually you can see the downforce is about 532 Newton, and the drag is about 159 Newtons. So these are the magnitudes of the downforce and the drag forces. Okay, so using this current simulation, we will do some post-processing, some basic post-processing procedures, and your analysis could be based on the skills in here, and then combine them to develop more advanced analysis. Okay. So let's open the geometry. We can open it in here. And then we can go to this pad. And now the geometry, the front wing is hidden. In order to show it, and there are several ways you can do it. So by clicking this, you can see the geometry. And also what we can do is to disable the outline, let the outline not showing, double click this symbol. So the outline, the lines are hidden. And for now, I just want to show the front wing. So I open parts region, I highlight, select the other regions because subtract color phase 1 is front wing. And then I just hide the rest. So you can see the front wing. And now we don't need to transparent it. We just make it non-transparent, and you can see this is a front wing. And we just simulated half of the wing because it's symmetrical geometry. Now, in order to do proper analysis, want to mirror the other part, let the other half showing. That would be makes more sense and looks better, right? In order to do that, we need to create a region, copy a region, the same region, and mirror it. This is what I'm going to demonstrate. So we go to regions and select the region. And now what I do is copy and click regions and then paste. So we will have exactly the same region. So region 2 is a mirrored part. And now they are overlapped, okay? So I will do the mirror. Right click region 2, transform, reflect. And we're reflecting about a plane along z-axis basically. So we have z being 1. We apply it. Okay, so it has been mirrored. And you can see, I think we can see it by also clicking here. And you can see the two halves, but this part is not in the right position. So what we are going to do is to move it towards the right hand side. So we do click region 2, right click, transform, translate. Okay. And then what we do is along z-axis, but minus. So let's do minus 1.5. Let's see how it works. And now we are making this geometry. Still, it's not in the correct position, but now we are going a bit smaller step. Move it towards the right, negative z further. and further. Okay, so let's see. And still the overlap is not good. Let me disable the shade. And now I will open another geometry. Okay, so let me close this one. And yeah, you can see there's still a bit overlap. And I will move it further, translate, and minus 0.1, apply. Okay, so now it's a good position. And let me now disable all the outlines and all the unselect, hide the other surfaces. Hide. Now you can see the front wing as an entire geometry. Okay, so this is done by first mirroring region 1 and then translate the mirror region. Okay, so this is what we have. And the first thing we want to check is the pressure distribution on the geometry. Okay, so what we do, there are several ways we can do. We can click here and then choose Scalar, or we can click here and then new displayer and Scalar. So let's do this way, new displayer, Scalar. Okay, and now you will see a Scalar tab. And so what we want to do is to display the pressure distribution over the front wing geometry. Okay, parts, then we need to select the right part and region. So that's this region. And also in this region, we choose both. Okay, and then we need to choose a scalar field. And as I said, we want to do absolute pressure in here. Okay, so now you can see the pressure distribution, right? And probably you find there is a bit low pressure and on the lower side, close to the leading edge of the front wing, but the rest is pretty higher pressure. If you want, and because on the top surface, the color are quite all warm colors like yellow and red, so we don't see a lot of resolution. So what we can do is we can change the color bar. Yeah, so we can change the color bar, scalar 1, and let's do this. Click a scalar field, and the range is now auto range, minimum and maximum value, and we are disable it. And then although the pressure difference are not huge, so we can say 10,000. Oh, good. Sorry, 100,000. And now it's better to see. And you can find there's a lower pressure on close to the trailing edge of the wing, and also lower pressure in here. And if you want, you can create proper 3-view and parallel and views, standard view. This is top view. And if you want, you can also change the contour type, smooth. It will make it smoother, right? And smooth field or blended. Let's see what happens to this. This one seems looking better. And you can see here is a higher pressure. This is a lower pressure. And this will contribute to the, you can see the pressure development on the surface. And this is top view. And also you can create side view. And there's higher pressure in here and also on this part of the wing. And rear view if you want. Or front view. Let's do front view. Yeah. This is not front. This is a rear view. Okay, so this is what we can see, the pressure distribution over the surface. And because data, the pressure on the lower side at the trailing edge is far smaller than this, so it's not showing. It's beyond the range. Okay, so this is pressure distribution over the wing. We can also change the scalar in here, change scalar field. And for example, we can change, because velocity here we applied non-slip boundary condition, all the velocities are the same. And if we want, we can see the y plus, which is also a very important parameter, which measures the Reynolds number. Basically, it's about the how close the grade, the first grade is away from the wall. And apparently, because y plus is 0, there's no velocity. It's just showing as 0. Okay, maybe it's not appropriate value. We can change the scalar to something else. Friction, skin friction coefficient. Okay, so you can see the where is higher friction, where is lower friction. Apparently, again, the range, color bar range is not appropriate. Although there are very high values, but most of the regions are very dark blue or light blue, so we need to change the magnitude. Also, we can disable this minimum and the maximum. And now let me reduce the range. So we need to disable. Minimum is fine, and we just need to reduce the maximum. Let's say 40. Let's make it 40. See what happens. Okay, so you can see there is a better use of color. The whole spectrum are nearly used. We can also reduce it to 20. Oh, this looks better, and you can see the distribution where friction is larger. So apparently the friction is larger, close to the trailing edge, and also somewhere in here if we have a lower view, and you can see the what happens. Okay, as a quick summary, in this part, we managed to do the reflection of the region or the geometry. Now we can see the front wing as a entire geometry instead of being a half. And second is how to visualize scalars over the formula front wing. In the next part, we will see how to check the slices, this flow quantities in the slices of the flow and in different orientations.